Welcome to this video tutorial on applying the biological perspective to health and social care. The aim of this video tutorial is to help students consider how biological perspectives can be applied to health and social care. By the end of this video tutorial, learners should be able to explain how biological perspectives can be used to explain and understand developmental norms. Learners will be able to describe how the biological perspective can be used to understand genetic predisposition to certain illnesses and health-related behaviours, and also to discuss how the biological perspective can be used to understand the effects of shift work on individuals. Understanding developmental norms. Giselle developed an assessment scale to enable judgments to be made about whether a child's behaviour and understanding matches that of their chronological age, which is how old the child is. This scale enables the children's scores to be compared against the scores at an earlier age to determine whether development is proceeding satisfactorily. It also enables a skilled and trained assessor to identify developmental problems that may emerge for an individual, thus allowing for early and appropriate health and social care intervention. Understanding genetic predisposition to certain illnesses and health-related behaviours. While it is difficult to determine the extent to which genetic inheritance influences behaviour, there is considerable evidence suggesting that genes do have a role in behaviour. One example is infantile autism, a rare disorder which affects about one child in 2,000. Whilst there are some psychological explanations for autism, these have not been satisfactorily investigated, and current research shows that genetic influences play more of an important role in the disorder of autism than psychological perspectives. Furthermore, the disorder of schizophrenia similarly shows a genetic link, though not as strong as in autism. In monozygotic twins, which are identical twins, who share all their genetic material, 50% of schizophrenia cases occur in both twins. This percentage is known as the concordance rate. However, in dizygotic twins, non-identical twins, who share half as much of their genetic material, schizophrenia only affects both twins in about 15% of cases. Sarafino and Goldfeder investigated the concordance rate for asthma. They found that 59% of monozygotic twins, which was 23 out of 39 pairs, were concordant for the disease, compared with 24% of dizygotic twins, which is only 13 out of 55. So, if schizophrenia and asthma are genetically determined, like cystic fibrosis, twins who share 100% of their genes should both, in theory, develop the particular disorder. There is clearly a genetic component in both these diseases, since monozygotic twins show a higher concordance rate than dizygotic twins, in line with the proportion of genetic materials shared. When practitioners work shifts, particularly night shifts, they tend to find that there are certain times when they feel an overwhelming urge to sleep while they should be working. Alternatively, when they go home after the shift and try to sleep and get refreshed for the new day, they may find themselves pacing the floor, unable to sleep. These unpleasant physical effects occur because of disruption to the biological rhythms. These biological rhythms govern a cycle of physiological body processes which last for between 24 and 25 hours. One example is our core body temperature, which follows approximately a 24-hour cycle and influences our levels of alertness. For most people, the lowest core temperature, 36.1, and the highest, 37.2,